So you might have heard that the support of the machines are non-linear machine learning models. That is, in the SVMs, the popular known as the SVM machine learning models, it separates the classes using it is capable of separating the classes using a non-linear decimal boundary also. That is, if we have the two classes in the two dimension space like this, you might have seen that support vector machines can separate these classes by a non-linear decimal boundary like this, a circular arc or a ellipsoidal shape. So this were the support vector machine learning model. But is it truly a non-linear decimal boundary? Actually, no. Support vector machine still is performing linearly only. So first of all, let me share what is linearly separable. So if we have a data set like this, it is a linearly separable data set. Why? Because we can separate both of these classes, class X and class 0, using a straight line, a simple one-dimensional hyperplane. But in a non-linear the data set is not linearly separable like this. We will not put any line that separates both the classes perfectly. But a non-linear direction can separate both of these classes perfectly. So this is called a non-linearly separable data set. And different type of machine learning models, that can be used here are simply the logistic regression and all that stuff. But here the logistic regression and the simple machine learning models are not different. Though, so that's why the streams came into the picture. But support of the machines also are not completely non-linear machine learning models. What they do is actually linear separation only, but to us in the low dimension space, it looks non-linear. And this is where the due to the kernel set or what we call properly called as kernel functions. So what are they actually? I will just tell you. So in the support of the machines, uh, how do we separate the classes? Imagine we have a linearly separated data set. If it's a wide street, this just for example in the linear regression, you set a line, right? In the support of the machine, you set a street, a road, a very wide street. So you are more confident of the data point that is lying on difference. For example, if you use a line, then you might be very confused at where these points lie actually. That is, in some cases, this can be technical, but sometimes it will not be. But instead, if you use a wide street, you are more confident of your prediction because you are separating them by a larger distance. So this is the main advantages of using separation. Now back to the topic. Imagine if we have a linearly separable data set, how will the support of the machine system? It will build a hyperplane, a linear hyperplane, which is can be W transpose X is B equals to 0. And it will build two more lines which are parallel to the main hyperplane. And these equations are W transpose X plus B equals to 1 for this. For this, W transpose X plus B equals to minus 1. The equation can be changed, but this R equation always remains. And these lines always remember these are parallel. Now, these are called support vectors. And hence the name support vector machines. Because and these all three lines together make the whole wide space, which make our own prediction in the SVM case more confident. Now, this was the linearly separable data set. Okay. Imagine we have a data set like this, or in the form of two constant circuits. Now, we can not find a line which can separate both the data sets perfectly. Never. So you try to fit this curve on this data set, and you will say that okay, it's a non-linear decision boundary, but actually it's not. It's still linear. What happens is that he was seeing this data set in the form of two-dimensional space. The code of the machines, what they do, they have a special type of function or a thread known as kernel functions. These kernel functions are applied to the whole data set, and they increase the store the data points into much higher dimensional space. What I mean by this, imagine we have a let's take the same case. We have this two-dimensional data set type of circle on one process and the process on another circle. The two conceptual circles can use one imaginary circle in mind. This one two-dimensional. After the kernel functions employed by the SVM work on this whole data set, and project the data set into three-dimensional space. So now we are looking at data set from a three-dimensional point of view. This is viewed right now in a three-dimensional space. And while this is happening, because of the kernel functions employed by the SVM. Now, the process will now lie like this on level 1 and on level 2, separated by some distance in the z axis will be the class 0. So now you see there is a clear separation between them. The height, which was earlier in the two-dimensional shape, height was being vanished because we were looking at the whole data set from an upper point of view. But when you saw it from a different three-dimensional point of view, the height was clearly predominant. So now the support of the machine is able to find a linear hyperplane, a linear plane. So you know this is a linear hyperplane, a linear plane simple. It can separate both the classes, class 0 and class X. And when you see from this, now from three-dimensional point of view, this is linear to you. But from two dimension, do you know what happens? Yes, you will see a clear separation. When you project the shadow on this plane, it will, what will it project into? Yes, a simple circle. Just project the whole shadow of this class 0 on this linear hyperplane. It will give a small circle separating with the X class from two dimensions. So in the low dimension space, it looks like a circle, but in the high dimension space, actually it's a linear hyperplane. So it's just a matter of perspective that changes the non-linearity of the data. Right?